You will understand why AI's explosive growth is creating an unprecedented energy crisis that threatens to reshape global power grids and infrastructure spending.
Every time you ask ChatGPT a question, somewhere a power plant burns enough fuel to keep a light bulb glowing for minutes.
That's not a metaphor! That's Sam Altman's own admission! And here's the problem. ChatGPT now handles over 1 trillion queries every year. The energy bill? $3 billion. Just for one AI service. From one company. Now multiply that by every AI model being built right now. Google just released data showing a single AI prompt consumes 10 times more electricity than a traditional search. MIT Technology Review called it a first, the kind of transparency companies release when they can no longer hide the scale of what they've built. But the real crisis isn't the energy these models consume.
It's that the power grid physically cannot deliver enough electricity fast enough to keep up with how quickly AI companies are building data centers.
Projects worth billions are stalled. Utility companies are turning away new connections.
Electrical transformers, the infrastructure that actually moves power from the grid to these facilities, have lead times measured in years, not months.
And the newest models? Researchers estimate GPT-5 will consume 8 times more power than GPT-4. This is not a future problem. This is happening right now. What you're about to understand is why the AI revolution is hitting a wall that no amount of venture capital, no breakthrough in algorithms, and no hype cycle can solve.
This is a story about transformers. Not the AI kind, the electrical kind.
The massive multi-ton pieces of infrastructure that take years to manufacture and without which every data center on Earth is just an expensive, empty building. You'll see exactly how much energy these AI models actually consume.
You'll learn why utilities are rejecting billion-dollar data center projects.
And you'll discover the hidden bottleneck that could determine whether AI expands or stalls. Because this isn't about code, it's about concrete, copper, and cooling towers. Let's start with what's actually happening inside these AI systems and why the energy math is spiraling out of control. When you type a question into ChatGPT, it doesn't feel like you're doing anything resource intensive. The response appears in seconds. Clean, effortless, almost magic. But behind that interface, thousands of GPUs are firing in parallel, pulling massive amounts of electricity to process your query through billions of parameters.
Independent analysis from data scientists and energy researchers is now cutting through the marketing claims. Articles titled, "What is AI's environmental cost? What the data shows," are no longer speculative think pieces. They're empirical breakdowns of measurable consumption.
And the data is stark. Sam Altman himself admitted that the energy needed for an average ChatGPT query can power a light bulb for a few minutes.
That might sound trivial until you remember the scale. Over 1 trillion queries every year.
That translates to $3 billion worth of energy annually. Just to keep ChatGPT running, not training new models, not expanding infrastructure, just responding to user prompts. Now, there's a growing push for transparency in AI energy consumption, and it's not coming from altruism. It's coming from the fact that the numbers are becoming impossible to hide. When Google finally released data on how much energy an AI prompt uses, MIT Technology Review called it a first.
The kind of disclosure companies make when they realize silence is no longer an option.
And the trajectory is accelerating. Researchers estimate that OpenAI's GPT-5 will consume over 8 times the power of GPT-4.
Not twice, not 3 times, 8 times. That's not linear growth.
That's exponential energy demand hitting physical infrastructure that was never designed to scale at this speed. Traditional data centers, the ones running cloud storage, streaming services, enterprise software, were already pushing grid capacity. But AI workloads are different. They require what's called high power density, more watts per rack.
more concentrated electrical load in a smaller physical space.
And that changes everything. Some industry voices have tried to downplay the crisis by comparing AI to other digital services. Forbes published analysis suggesting AI is almost green compared to Netflix, Zoom, YouTube, and technically on a per query basis that might be true.
But here's the twist. Netflix isn't doubling its infrastructure every 6 months.
YouTube's energy consumption is growing, but predictably.
AI data centers are being built at a pace that makes those comparisons irrelevant.
Because the bottleneck isn't just total energy consumption.
It's the physical impossibility of delivering concentrated power fast enough.
And that's where the real crisis begins.
Here's what most people don't understand about the power grid. It's not a magic reservoir you can just plug into whenever you need electricity. Getting power to a data center requires transformers. Massive electrical transformers that step down high voltage transmission lines to usable levels. These aren't off-the-shelf components. They're custom manufactured multi-ton pieces of industrial equipment. And right now, the lead time to get one, years, not months. Years.
Major research institutions like Pew Research are now tracking this crisis in real time.
Their reports on U.S. data centers' energy use amid the artificial intelligence boom show a system under unprecedented strain. Utility companies are facing a flood of requests for new data center connections, and many are simply saying no.
Not because they don't want the business, not because they're anti-technology.
Because the grid physically cannot handle the load, this is no longer just an industry problem.
It's now part of the global energy demands within the AI regulatory landscape, a policy-level crisis that governments and regulators are scrambling to address.
And here's the kicker. Even with tightening efficiency standards, data center electricity use surged in 2025. The International Energy Agency confirmed it. Despite all the optimization efforts, despite all the cooling innovations, consumption growth is outrunning efficiency gains.
Now zoom in on the local level, where the consequences become real.
In Northern Virginia, one of the largest data center markets in the world, utility companies are turning away new projects.
Billion-dollar investments are being delayed or relocated because the grid can't deliver the power. In Ireland, data centers already consume more electricity than all the rural homes in the country combined. The government has imposed a moratorium on new connections in certain regions.
In Singapore, one of the most advanced tech hubs in Asia, regulators have paused approvals for new data centers entirely.
These aren't hypothetical scenarios. These are active, documented cases of infrastructure limits overriding market demand.
And it gets worse. Even when companies secure grid access, they face another problem: cooling.
AI chips generate enormous heat. Keeping them operational requires industrial-scale cooling systems, and those systems need water. Lots of water! Some estimates suggest AI data centers consume millions of gallons of water per megawatt of cooling capacity. In drought-prone regions, this is creating direct conflicts with local communities over resource allocation.
Independent researchers are now actively scrutinizing industry claims.
Articles like Let's Analyze OpenAI's claims about ChatGPT energy use are dissecting corporate sustainability reports and finding gaps between what companies say and what the data shows.
This isn't conspiracy theorizing. This is the expert community fact-checking an industry that grew too fast to regulate itself.
And here's the hidden consequence almost no one is talking about: stranded assets.
Companies are building data centers in regions where they think they can secure power,
only to discover that utility upgrades will take 5 to 10 years. So you end up with billion-dollar buildings sitting empty, fully constructed, fully wired, but completely useless without electricity. The industry calls them stranded data center assets. The rest of us would call it a colossal infrastructure failure.
So what does this actually mean for the future of AI? It means that the bottleneck isn't compute.
It isn't capital. It isn't even talent. It's transformers, transmission lines, and cooling towers.
All the venture capital in the world can't solve a transformer shortage.
All the algorithmic breakthroughs can't overcome a utility company's capacity limits. And remember, GPT-5 is estimated to consume 8 times more energy than GPT-4.
If that trajectory continues, every new generation of AI models will require exponentially more infrastructure. Now, some companies are trying to solve this themselves.
Microsoft, Google, and Amazon are all exploring partnerships with nuclear power plants.
They're signing power purchase agreements directly with energy producers.
Some are even considering building their own generation facilities.
But nuclear plants take a decade to build. Renewable energy procurement at this scale requires land, permits, and grid integration that takes years. There is no fast solution here, and that creates a profound strategic question. If AI companies can't get the power they need, what happens to all the promises about artificial general intelligence, about transforming every industry, about reshaping society?
Those promises were built on the assumption that infrastructure could scale as fast as code.
It can't! Here's the even darker twist. This energy crisis is creating a new kind of inequality. The companies that already have power, the ones that built data centers 5 or 10 years ago in regions with grid capacity, have a massive, insurmountable advantage. New entrants? Startups trying to compete with OpenAI or Google?
They're facing infrastructure barriers that no amount of innovation can overcome.
You can have the best AI model in the world, but if you can't power it, it doesn't matter. So the AI revolution is hitting a wall, not a wall of imagination. Not a wall of talents, a wall of concrete, copper, and kilowatt hours. And the companies that solve this problem won't be the ones with the best algorithms. They'll be the ones with access to electrical transformers and utility agreements. 1. Energy consumption is now the limiting factor for AI expansion. Algorithms are advancing faster than the power grid can support them, and no amount of capital solves a transformer shortage. 2. Infrastructure transparency is increasing because companies can no longer hide the scale. When Google releases energy data for the first time, and researchers estimate GPT-5 uses 8x more power than GPT-4, the crisis is undeniable. 3. The real winners in AI will be determined by access to electricity, not just talent or funding. If you can't secure grid capacity, your data center is just an expensive, empty building, and that changes the entire competitive landscape. If you want more investigations like this, stories about the infrastructure, the money, and the consequences behind the hype, subscribe now!
Tomorrow's video breaks down the hidden costs of another technology everyone thinks is inevitable.
You won't want to miss it.